This is Math 133, aka Calc 2, Chapter 11, Section 10, Taylor series. So what we're going to be doing is finding the Maclourin series for f of x equals sine 3x squared. And so I wrote down that function right here, and then we're going to take the derivative of it. So the derivative of sine 3x squared is 6x cosine 3x squared, because what you want to do is you want to take the chain rule when you're taking sine 3x squared. So then you take the derivative of the outside and then multiply it by the derivative of the inside. Well, you'll keep doing this for a little bit, and then your answer will keep getting longer and longer. And then I brought it up to this point, to this really long function right here. And the reason why I skipped these other inside bits, spoiler, they don't really come out to anything. It just comes out to 0, so they're kind of irrelevant. Well, as you know, once you get to this point, once you take the derivative of it, you plug in x. Well, since it's a Maclourin series, you just want to plug in x equals 0. So, our original function, if you plug in 0, it basically just comes out to sine of 0, and sine of 0 is just 0. Okay, well, the derivative of it would be, since it was 6x cosine 3x squared, it would be 6 times 0 multiplied by cosine 0. Well, we know cosine 0 is 1, but it's still being multiplied by 0, so the answer is going to end up being 0. Well, this third one, or second derivative, when you plug in 0 into the cosine, it'll be 1, and because it doesn't have an x in front, it's not multiplied by 0. So then, this actually ends up being 6 multiplied by 0, because this sine is 0, multiplied by 0, so just 0, plus 1. Well, 0 plus 1 is just 1, so 6 times 1 is just 6. And then, because it's the second derivative, you multiply this by x minus a, when our a is 0, so it'll just be x. And then it's to the power of whatever derivative it is. So that'd be, since it's the second derivative, it'd be squared. Then divided by 2 factorial, because this is the second derivative as well. And 2 factorial is basically just 2 anyways, so 6 divided by 2 is just 3, so the answer would end up being 3x squared. Well, like I said before, these next ones just end up being 0, so there's that. Then you get to the really long one, that was right up here near the top, and, you know, if you look, well, sine is 0, 0, so this entire thing right here, 0. Well, cosine 0 is 1, but still being multiplied by an x. Well, this x would end up being 0. 1 times 0 is 0. Then plus this, sine of 0, it's 0, minus 540 cosine 3x squared. Well, it would be 540 times 1, so this actually be negative 540, which is right here. But then you can't forget to multiply by the 6 that's on the outside. So 6 times negative 540 is negative 3,240. Then because this is the 6th derivative, it would be x minus 0 to the 6th power, which is just x to the 6th, divided by 6 factorial. And then 3,240 divided by 6 factorial ends up being negative 9 halves, which is negative 4.5, and then x6. Well, doing this on any normal problem, taking the derivative 6 times is not optimal. That takes a very long time, especially since this is already so complicated up here, and then it just gets worse, 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 and worse. And then, again, this is only the first 2 numbers that you get out of this. So, a second way to do this, which is also easier, is if you recall back to 11.10.7, we were given what the Maclourin series for sine of x equals. That's negative 1 to the power of n multiplied by x 2n plus 1 divided by 2n plus 1 factorial. Okay. Well, we have our function 3 of x squared. So if we just plug this 3 of x squared into the x, we get the same thing, except it's 3x squared to the power of 2n plus 1. Okay, so now let's plug in n equals 0. So negative 1 to the power of 0, that's just 1, so that doesn't really matter anymore. And then if you plug in 0 into the n, it should be plus 1 up here. So it'd be 3x squared to the power of 1 over 1 factorial. 1 factorial doesn't really mean anything, it's just 1. So the answer just ends up being 3x squared. Okay, so now let's plug in n equals 1. Well, negative 1 to the power of 1 would be negative 1. So you got to make sure you keep that negative in here. Because with the sign of x, it keeps flip-flopping on whatever it's positive and negative. And then you plug in the n up into here and down here. So it would be 3. So 2x squared to the power of 3 over 3 factorial. Well, don't forget to take the power of 3 to both 3 and the x. So it would be negative 27 and then x6 with this over 3 factorial. Well, 3 factorial is just 2 times 3, which is 6, so 27 divided by 6. If you lower that down, you can get to negative 9 over 2, times x to the 6. Well, right up here, that's the same answer. Okay. But this is way easier already. But, we can take this even further, and we can put in n equals 2. Okay. So, again, this becomes positive, and then plug in the 2, so 2 times 2 is 4 plus 1, so we get 5 up here and 5 down here. So then 3 to the power of 5 is 243, and then x squared to the power of 5 is x to the 10th. So 243 over 5 factorial becomes like a really weird number of like 2.025, but that just ends up being 81 over 40 to x to the 10th. And like you can keep going with this, and like this way is way easier if you can just recall the formula that we're given in 11.10.7 to come up with these answers faster than taking the derivative a crap ton of times. Okay, now comes on to the second question. True or false? The power series expansion for f of x, gx as 0 is given by f of 0, g0 plus f prime of 0, g prime of 0, x, and then so on and so forth. Well, this right here would be the derivative. Well, we know when you take the derivative of something and it's like two functions next to each other, then you have to do the chain rule. So then you would do f of x, g of x, the derivative of that would be f prime of x times g of x plus f of x times g prime of x. So then already right here, just off of the first derivative, we know that this is false because this doesn't line up right here. So the answer is false, and we don't even have to continue on to figure out that one. And that is it.